Okay, this is section 6-9, Algebra 2, solving log equations and inequalities, page 437. Okay, I think there's 2 or 3 questions on the test about this. So a logarithmic equation, I just call them a log equation. If you look on that page, contains one or more logarithms. Okay, most of the time there's a variable somewhere in there. Okay, that's a log equation. How do we solve them? Well, let's take just a couple examples here. Here is an example of a log equation. The log of x base 36 equals 3 halves. Okay. This is a log equation because it does have a logarithm, and the variable is in this position. Okay. When we have it like this, and like I said, you'll have it. I know that you guys are used to writing an exponential way, a certain way, but it's best if you do it this way because the inequalities are coming. It is leave the x on the left side. Okay. Now, which of these two numbers is the exponent? 3 halves. Logarithms isolate the exponent. Okay. So what we have then is 36 to the 3 halves power. Okay. Now this means the square root of 36 cubed, where the square root is the bottom number, the root is the bottom number, and the power is the top number. So we have x equals 6 to the 3rd power. And that is, I believe, 216. X 6 times 6 times 6.
So the bottom number will always be
The root.
and then the top is
The power, yes. So let's say that I have this one, number 2. The log of x base 16 equals 5 halves. Okay, we leave the x on the left side. So we have x equals, and this is a power. So we have 16 to the 5 half power. This base is this base. So that means the square root, bless you, 16 to the 5th power. The square root of 16, I believe, is 4, is it not?
Yep.
So x equals 4 to the 5th power, which equals 4 times 4 times 4 times
1024.
1024. Okay, thank you. Yes.
Will the base always be 2?
No.
Yeah, what did we do?
So if it's 3, this will be the cubed root. And this number usually has a perfect cube root, like it'd be the cube root of 8.
Yeah.
Okay?
Yep.
All right. So if you look there, there's a property of equality for logarithm functions. It says that, I'm just going to say it this way. If the log of x base b equals the log of y base b, then they have the same base, right? Then x must equal y. We've talked about this a little bit before. So if you have 2 logarithms and they have the same base, then this value must equal this value. Okay? So let me give you an example. We can solve an equation like this. Number 3. If we have the log of x squared minus 4 base 2, and that equals the log of 3x base 2. Okay, since they have the same base, this theorem says that this value must equal this value. So we can drop the logarithms and we can just say x squared minus 4 equals 3x. Okay? Now, since it has an x squared and an x, this is what we call a quadratic equation. So we're going to put it all on one side and try to factor it. Yeah. So we're going to reverse FOIL. We get x minus 4 times x plus 1. So my possible, now I say possible, my possible values are 4 and a negative 1. You see that? Okay, if we put 4 in, we get 16 minus 4, that's log of 12 base 2. The same here. If we get 4 here, it's log of 12 base 2. So 4 works. But if we put a negative 1 in, a negative 1, this is a negative 3x. You cannot get a number to equal a negative. You can't take 2 to any power and get a negative number. Therefore, this is thrown out. And my answer is simply 4.
Negatives will always be thrown out, right?
If it's in this position, yes. Okay? They'll be thrown out. All right? So, let's take this one. Do this one if you would. The log of x squared minus 15 base 3 equals the log of 2x base 3. Since they have the same base, this quantity equals that quantity. You put it all one side. And you factor it, reverse FOIL. I believe it's 5 and 3, correct? Okay, so my possible values are 5 and a negative 3, is that correct? Which one don't you think works?
Negative 3.
That's correct. Negative 3 does not work because this becomes a negative 6x. This actually becomes a negative also. Doesn't matter if they're equal.
I don't,
Harper, go ahead and ask.
no, I got it.
You sure?
Yep.
All right. Any more questions? Okay, so you remember how we did these? Maybe I'll try to do this one on this page because it kind of follows this. Okay, so let's change this to an inequality. All right? And if you look there on page 438, maybe I better write those down before. It says, this is the property of inequality for log functions. It says, if b is greater than 1, has to be, that means, and x is greater than 0. So that's positive. And the log of x base b is greater than y, then x is greater than b to the y. Okay? So it's a lot like this, only we have a greater than. And you're good, right? You're good there. Okay? However, if b is greater than 1, your base is greater than 1, and x is greater than 0, so this value is positive, okay? And the log of b, or excuse me, the log of x base b is less than y, then 0 has to be less than x, it has to be less than b to the y. And I'll explain this to you in a minute. Okay? So let's take a look at this 5. Greater than is great. Greater than is awesome. Okay? It's less than that you have to remember. Less than has got a whole different problem. But let me show you this. Let's say that we have the log of x base 4 is greater than or equal to 3. This is a good one, right?
Mr. Ellis?
Yes.
Could you pick up, please?
Yep. Yes. Okay. Okay, all right. Okay. Okay, all right, thank you. Bye-bye. Probably heard all that, didn't you?
No.
It'll be on the video. Anyway, it's still going. I didn't know how to pause it, so the video is still going. So anyways, you see this? You see this? You remember this? We would go x is equal to 36 to the 3 halves. Same pattern. X is greater than or equal to what? 4 to the 3rd power. So what we get is 4x x is greater than or equal to 4 to the third power is, I believe, 64. Got it? Now, here's the hard one, and it's not that hard, you just have to remember, that's the problem. If we have the log of x base 2 is less than 4, we got to be careful here, because remember we can't use negative numbers, right? So what we have is, remember you can't use negative numbers, we have x is less than, right, 2 to the 4th, which x is less than 16, correct? But since it's less than, it's got to be greater than 0. So my answer is 4x. 0 is less than or equal to, no it can't be 0. 0 is less than x is less than or equal to, is less than, sorry, 16, just less than. Guys, this cannot be negative. Now we don't have to worry about it with greater than. Because greater than, if it's greater than 64, it's definitely not going to be 0, right? Correct? But if it's less than, if our answer is less than 16, it could be 0. Do you understand the difference? Really? Do you understand the difference? Okay. So if it's greater than, you're good. If it's less than, you have to put it, it's greater than 0. Okay? All right. Finally, on the next page, it says that if b is greater than 1 and the log of x base b is greater than the log of y base b, only if and only if x is greater than y and it's less than it, only if x is less than y. So it's the same as comparison. All right, but let me show you an example. What example is this? 7. Let's say that I have the log of x plus 3 base 4 is greater than the log of 2x plus 1 base 4. Do they have the same base?
Yes.
Therefore, I can drop the logarithms and say this. You got it?
So that base 4 doesn't have to do anything with it.
No, just as long as they're the same, Harper.
You can
If they're
drop that too.
exactly, then this has to be greater than this. And if this was a less than sign, this would be less than that.
Yep.
Okay, you understand that?
Yep.
Now I just solve for x. So I'm going to subtract x from both sides. Right? And now I'm going to subtract 1. So my answer is x is less than 2, correct? However, can these be negative? They cannot be negative. That means that x plus 3 must be greater than or equal to, actually we're just going to say they must be greater than 0, and 2x plus 1 has to be greater than 0. If I solve, this is x is greater than a negative 3, and this is x is greater than a negative 1/2. Is that true? Okay. So which is it? Is x greater than a negative 3 or is x greater than a negative 1/2? On the number line, here's a negative 3, here's a negative 1/2. Where do they start intersecting? One starts here and goes this way, one starts here and goes this way. Where do they start intersecting? Negative 1/2. So this is my lower value. It has to be between these two. So my answer is 4x, negative 1/2 is less than x is less than 2.
I just don't understand how you got the negative 1/2.
I moved the 1 over, so it was negative 1, and then I divided by 2. I should have showed that. So I have 2x plus 1 is greater than 0. So I have 2x is greater than a negative 1, divide by 2, divide by 2, x is greater than a negative 1/2.
And you just did the same for the other one?
Yes, I just solved for x. And then wherever they intersect, Uton, wherever they start to intersect, that's your lower value.
Okay, and so, and you only have to do that when x is less than something?
No, in this case, you got to have a lower value. These cannot be negative, so I have to figure out where it's not negative, and this will always be less than, I think, because this is your upper value. So if I do another one, Uton, okay, let's say that I have the log of 2x plus 1 base 5 is less than or equal to the log of x plus 4 base 5. Okay?
Okay.
Since they have the same base, then 2x plus 1 is less than or equal to x plus 4, correct? And I subtract x, I get x plus 1 is less than or equal to 4, and so I subtract 1, and I get x is less than or equal to 3, correct? This is my upper boundary. My lower boundary is determined by these two. If this was greater than, if my answer was greater than Uton, right here, I wouldn't have to do anything with these two, because my value is greater than they would be.
Okay.
Okay, so unless they're negative, we have to go 2x plus 1 is greater than 0, and x plus 4 is greater than 0. So this is like this one, it's exactly like that one. So I get x is greater than a negative 1/2, and x is greater than a negative 4. Where I have to check this is, where do they intersect? One starts here, and one starts here. Where do they intersect?
One.
They intersect there, so 4x, a negative 1/2 is less than x is less than or equal to 3. Notice that this one is less than or equal to, but this one's always greater than that. There is no equal to it. You can't have an equal because it can't be 0.
Okay.
Okay, now that's a coincidence, Uton, that these were both a negative 1/2.
Okay.
That's a coincidence. That's not going to happen all the time. Any questions on that? Okay, so your assignment, if one of you guys would write it down, is page 439, numbers 8 through 18 even, and 22 through 30 even. It is due Monday. Can I have one of you guys write that down up there?